will be narrating it now for y'all. So here we go. So this is the entrance to the SmallSat laboratory. When you go in, there's lots of workstations as well as the clean room, which is this orange looking facility to the right. This is a student workspace, and so there are lots of posters and fun things in the more lounge area of the SmallSat lab. They are funded by NASA and part of the University Nanosite satellite program. I'll go over some of their missions in just a second. They have a very extensive website, so I encourage you to check it out. I'm going to show you some of the scenes from there now, but if you ever get a chance to go by, it's in the physics building at UGA's campus, and you can actually see it from the outside. There's large windows that say UGA SmallSat Lab on the outside near the geography building, so check it out for sure. So this is part of their website. They recently launched their SmallSat Spock. And one of the cool things about their website is it is kind of interactive like this. So this is them describing the CubeSat. It's very small. It's 1.33 kilograms, so pretty small. And now they're breaking down the portions of the satellites themselves. So you have solar panels on the outside. You have the frame system, which obviously encases all the important features. As we go further into it, you have the ADCS, which is how it's controlled. Again, further, it's the next step is the payload. So this is where the scientific data is collected. The computer, which is definitely the heart of the satellite. And then, yeah, it's launched into space. So Spock is the Spectral, Spock is the Spectral Ocean Color Satellite, and it's funded through NASA. It is the SmallSat Lab, which we'll show in just a second some of the members, but it is made up of undergraduates and graduates here at the University of Georgia. There are other SmallSat programs at other universities, but I believe that we are the first to successfully launch this type of satellite into space. So it was successfully launched and is now working. Mochi, so this is the multi-view, Mochi is their second CubeSat that they're building. This one has not yet launched, but does plan to be launched in 2021. Mochi is the multi-view onboard computational imager. And so all of these satellites are requiring satellite imagery in low orbit. And MEMESAT. So this is the Mission for Education and Multimedia Engagement satellite. And of course, they have broader interests as part of the SmallSat Lab. So the primary investigators, the timings are a little bit off. The principal investigators are Dr. Deepak Mishra of the Geography Department and Dr. David Cotton, who is also part of the Geography Department as well as Physics, I believe. Like I said, there are many graduate students, but they are from different departments, not only geography and physics, as well as undergraduate students from engineering. There are all different kinds of students from all over campus that put a lot of effort and a lot of their time into this SmallSat program. Mission operations, technical team member, of course, lab operations, which are extremely important. And of course, the faculty investigators that are the backing. So our own Dr. Marguerite Madden is in there. Dr. Marshall Shepard is also from the Geography Department. And of course, there are many sponsors of the SmallSat Lab, including NASA Ames, which they have a Space Act agreement with NASA to test the CubeSats. There's the NASA USIP, which is the funding agency for the Spock mission. The University NanoSat program, which I already talked about a little bit, is the project partner for the MOCHI mission. And then, of course, I didn't mention this when I was talking about MOCHI earlier, but they are funded by the Air Force Research Laboratory, as well as the Georgia Space Consortium for Spock, Georgia Space Working Group, AGI, Georgia Sea Grant, Johns Hopkins APL, which is Advanced Processors, and SpaceWorks. So in summary, the SmallSat Lab is a wonderful part of the University of Georgia and is helping further the collection of satellite data and GIS as we move forward with these new CubeSat technologies. All right, I'm going to hand it back over to Amanda and Austin, but thank you for letting me guide you through the SmallSat Lab. And again, thank you to Dr. David Cotton for allowing me access.
Thank you, Caroline. Wow, that's quite a lot going on in SmallSat Laboratory. I'm going to go ahead and open up for questions. If anybody would like to ask a question, you could write it on the chat or raise your hand and I can unmute you. So if there's any questions, please ask. All right. Well, we have a thank you. Okay, if we don't have any further questions. Oh, all right, from Austin Stone. How big are the CubeSats again?
Yes, so the CubeSats, hold on, let me pull up the details really quick. The CubeSat is pretty much the new standard for small satellites, very small. They are 10 centimeters by 10 centimeters by 10 centimeters. So think about a tissue box is how I usually describe it. It's like, it's not very big. So the entire satellite itself is 1.33 kilograms.
Great.
Yeah, so they're very small. There are other satellite agencies that are like commercial agencies that are pursuing small sats. Planet, I believe, is one that has high resolution, high frequency data. But each of these small sats were actually built and tested, and all of these things are involving students, which I think is really, really cool and an amazing opportunity for students to actually get their hands on, have an idea, and build from scratch.
Awesome. And we have a comment here from Marguerite Madden. She says, so the size of a Beanie Baby box.
Yes, and it's clear like the Beanie Baby boxes. That's a great reference, Dr. Madden. So Spock, let me read you again the definition of their mission. So Spock is the Spectral Ocean Color Satellite. It is a satellite mission that was founded through NASA's second iteration of undergraduate student instrument projects, USIP, in mid-2016. So the satellite lab, I believe, was founded in 2015, is kind of when it first started, not the physical lab itself, but the group of people. Spock's mission is to acquire moderate resolution imagery across a wide range of spectral bands to monitor coastal ecosystems and ocean color. So Spock will acquire images between 433 and 866 nanometers to monitor coastal wetland statuses estuary water quality, including wetland biophysical characteristics and phytoplankton characteristics, as well as near coastal ocean productivity.
Excellent. Quite a mouthful there.
Yeah, it's a lot, but basically it is to assist in the monitoring of coastal wetlands.
Okay, I have a question. What is the current status of the small sats?
So this small sat in particular, Spock, has reached the International Space Station, and I believe that it has been deployed. So it is currently collecting data, and there's actually a website that you can visit to watch the it's like a dashboard. Here, I will share my screen.
Okay, and as you're doing that, I'm going to read a comment from Marguerite Madden. She says, oh, and they built the ground receiving station that is on the roof of the geography building too. They will receive the images when Spock goes over the building twice a day. Wow. So if anybody's walked by the geography building, just look up and you'll see this giant parabolic dish on top of the roof. And that is the ground station. We right here on campus, we are receiving images from space.
Mm-hmm. And if you see here, so this is Spock. It has in the current time as of today, and it is currently in safe mission mode, and you can tell all of these various parts of the satellite as well, the battery voltage here. Temperatures, and then yeah, so frames that it has taken as well.
Wow, this looks like something straight out of a sci-fi movie.
It does.
Well, we have another question here. What agency launched Spock? Was it on the recent SpaceX mission? And this was asked by Corey.
That's a good question. I personally, I'm not a member of the Small Satellite Lab, so I don't exactly know the details, but if we maneuver here to the SmallSats website, I remember watching it launch, but I couldn't remember when or what it was launched on. Let's see. Maybe Dr. Madden has a better idea.
Okay, so Dr. Madden did reply, and she said the ham radio operators are hearing it, but the team is working on communicating with Spock. Once that happens, they will be able to tell it to take images. So I guess at this current point, it's not taking images because there's some interference, is what I understand from that comment.
Yes.
Is that correct? Oh, and Austin has responded, launched on a TARS, I'm not sure if I'm saying that right, rocket at Wallops Flight Facility on the coast of Virginia. Oh, okay, I am going to unmute Dr. Madden. I think.
Yeah, so it was really exciting. It was launched on November 5th, but they had a launch party at physics the day before. Everybody was there. Lots of high administration, David Lee, Vice President for Research, lots of people there. It did not go up because there were a couple of different theories about it, but it had to do with some programming that was not quite off. It got up to, I think like it was within 8 seconds or 11 seconds or something of being launched. So they scrubbed it, but it went the next day. And so it launched up, and actually I have a whole presentation on it that I gave to my air photo class, and I couldn't find it real quick. But it went up, went into orbit, and then it eventually reached the space station. And there's a movie of it docking, which is really interesting, seeing it from the perspective of the space station. And that actually is a hand-driven maneuver. It gets closer and closer and closer, and that at some point the astronaut in the space station takes over and actually guides it to connect. And then all of the CubeSats were unloaded, and it just got sent out I'm not sure what they exactly call it, but there's a chute that's built to launch out the CubeSats. And it went at 4 in the morning the other morning, and there's a picture of it. And I think you can probably hear this. There's a short video audio of, I'm gonna play it, see if this works. One of the astronauts talking about it.
And also huge thank you from universities of Georgia, Ohio, and Hawaii. Those are the SATs that were deployed this morning you got for us.
So just small, but that was from one of the astronauts on the space station. So then it goes into low Earth orbit. The dashboard shows you, like, will show you how long the battery is going to last, for one thing. It goes over twice a day, 5 in the morning about and 10:30 at night. That'll change as it goes along, but the team from the small sat lab comes to CGR, and so they come at 5 in the morning, and David will meet them there, or one of the other leads, and they're trying to communicate. There it is. So these are 2 CubeSats in tandem, and the first one is Spock. That one, that's Spock going out. So far the ham radio operators can detect it or see it's there. They know the battery's working, but they're not able to receive the communication, the ping that comes from it. And so twice a day they're trying to get that that capability. Once they get that communication, then they can give it the instructions to start turning on the imaging, the camera. And then once that happens, then they'll have some images that they can download to the ground receiving station. So it's and David said, he's hoping it'll be up there months. So it's a little nerve-wracking right now. They mobilize the team twice a day and try to get the communication going. And I haven't had an update in the last couple of days, so it could have changed. But that's the status that I know right now. This is the docking. Yeah. And that particular, I need to find that PowerPoint that I did for the class.
And Dr. Madden, I just want to mention, this is their Facebook page, so all this information can be seen on Facebook if anybody's interested in looking for these.
Great, okay. Oh, that's good, that's really good.
Yes, at the UGA Small Sat Research Lab is the name, and they also have a Twitter page that is pretty active as well. So UGA Research recently retweeted.
Oh, great.
Small Sat Lab. So
I need to do that. So I don't know how much time do you have?
Yeah, keep on going. We have
Okay.
time.
So I found the PowerPoint that I made for my class, and am I able to share my screen?
give me just a second and I should be able to allow you to.
Okay. I don't want to bore people, but I do have
this is
some
very
pictures.
interesting, and I'm very glad that we have you here, Dr. Madden, because obviously I'm not an expert. I do work with David, but yeah, please feel free.
I was just able to pop up into the lab into CGR every so often, and I didn't want to bug them, but I said, David, how's it going? And he would let me know. So.
And we are recording this so we can rewatch it and share it. And
oh, good. And they can make corrections too.
Yes, any corrections to me. Sorry, David.
Okay.
So our next panel is not till 5 o'clock, I believe. So we
oh my gosh. Okay.
Time to discuss this as long as we wish.
I won't keep you that long. Okay. So I think you should see my screen now.
Yes.
Great. Okay. And get out of this. Okay, there we go. So I took images off of the website as well. Okay. Oops. Okay. Just grab shots of the lab. I was just telling my this is aerial photographs and image and interpretation. A little bit about this, a little bit about the lab itself. Here's the ground station. It is super impressive. And what's interesting on the roof has a garden. It has a climate weather station. The building was built in 1956, and they built the grass up on top of the roof in order to have grass behind the weather instruments. So people had to mow the lawn, and it's the first garden on top of a roof in Athens. When Dr. Amy Trauger came as one of our faculty members, she put a garden up there, raised bed gardens, and her classes grow fruits and vegetables that they donate to the Athens Food Bank. We also have beehives up there. And there was a satellite dish. I don't know exactly what it did, but they had to remove that and then put this one up. So it was quite an undertaking. And these big antennas usually are straight up and down, but when they're trying to track for the satellites going overhead, then everything starts rotating, and this big dish will rotate around and try to track the CubeSat as it goes across the horizon. So, and then there are cords, big wires and cords that go across the roof. They go down the side and into the window into David's office, and then they connect to the computer there. Apparently they're going to eventually move some of this to somehow to physics, but for right now he has to keep a blanket or something in the crack in the window in order to stay warm during the winter. But it's an amazing operation that they built and put up there.
And for scale, you can see that ladder right next to it. That's
Yes.
gigantic.
Yes, it is very large. Yeah. So far the bees and the gardens and the ground station and everything is in harmony. So it's working up there. So this was about Spock. And I mentioned the Beanie Babies because it could be a legend, but that was apparently somebody at NASA like looked at their desk and their daughter's Beanie Baby box was sitting there. And so the challenge was, can we make a satellite that fits inside of a Beanie box? So that's where that dimension, so that would be a 1 cube satellite would be one of those 10 by 10 by 10. And it's funny because one of the founders here, he would specify it's actually not 10 by 10 by 10, it's like 10 by 10 by 9 or something. There's specifications of the dimensions, but then you can have a 2U or a 3U or a 6U, so it's very modular. And this is obviously a 3U CubeSat. So this was the satellite, the launch day. So the Antares was the rocket, Northrop Grumman built it. It was launched from Wallops Island. So this is Wallops, not space facility, but it is a rocket launch facility there. And so that's where the CubeSats go into the very top, and the top was called Cygnus. So that was the part that everything else broke away, and that's the part that went up to the space station. It was named after an astronaut, Kalpana Chawla, and so the Cygnus, I don't know what the name of it is, that part of the rocket was named after her, and she was part of the Columbia group that had the accident. So it was in her honor. This was the night that they had the launch party. And so there were a lot of activities, a lot of things going on. They had all kinds of people zooming in, and Roger, blank out his last name. He let's see, he works at NASA Ames, and he was a bulldog. He's a big bulldog fan and a great advocate for the whole project. And he came and he introduced everything. Dr. Mishra was there answering questions. They had a lot of the original undergraduates that had come together. There were 5 to begin with, and that quickly grew to about 50. The cargo on the Cygnus was interesting. This was a list of it. So besides the CubeSats, they had a new toilet. So a new compact toilet was coming on board. They were waiting for that. They were waiting for some lotions, Estee Lauder lotions, because they're up there for a long time. And then also different kinds of chocolates. So apparently they were craving some of these desserts. So they were really anxious for this cargo, this load to come. And they were disappointed with the delay. Here it went. We were, it was 2.21 minutes from launch. And, you know, we were all very expectant, and we were hearing all of the chatter back and forth, and, you know, and then it got to the point where it just said, abort, abort, you know, everyone was disappointed. But so some kind of ground software, and also high level winds. So they were monitoring the winds the whole time. Another thing that will scrub a mission is boats and airplanes. So they try to, you know, clear the area in case a rocket goes off, something happens, and the debris comes down. They don't want any, you know, chance of anyone in a boat or an airplane in that airspace being impacted. They make announcements ahead of time, but sometimes they will be monitoring it and they see a boat in the area, then they abort the whole thing. But that was rumored that happened, but I don't think it was. I think it was these high level winds and the software glitch. So the next day they got it fixed, and I was on NASA Live for that, which was super exciting. So NASA Live is something I didn't know about, but there's a schedule. You just go to the website, and all kinds of interesting things happen live. So for example, the last launch, they interviewed the 4 astronauts ahead of time. You got to get to know them a little bit. They had the launch. You know, they're going up to the space station too. You see the ground control centers, you know, talking back and forth to the space station. So I highly recommend that. That's really fun to do. So the launch was there and recorded. So this was the actual launch, and I think Tommy also was watching and grabbing screenshots from the video as he was watching it. So he posted those on Facebook. So that was really fun. This was what happened. What I didn't know about is that this all happened so fast. So within minutes. So here's the after the launch. So 3 minutes into the launch. So there's a main engine cut off, and then there's going to be a separation right after that. And then this part opens up, and the Cygnus comes out. And so I was watching, and you know, at this point it's not, you know, real video, but it's you know, recreation and animation of it. But then I was trying to capture the screen as this was happening, and the map here shows you the trajectory, and so they're really not very far off the coast when all of these separations happen, and they happen very close to each other. The altitude you see is like 50 miles up. You know, see how they're crazy velocity, so that's almost 10,000 miles per hour. So this is the phase 4 separation, and then it goes along for a little while. Phase 5, this is phase 8, I guess. It was amazing to watch the animation. That opens up, these pieces fall away, and the Cygnus comes out, and this is under its own power now. And it goes, and there's this other piece breaks off, and it just goes along. Eventually it gets to the space station, and this is a view from the space station looking at the piece it's going to dock with. And that round, I think it's this one right here, that's the part that's gonna grab it. An arm, this is the arm that comes out. So this is the astronaut in there it's you know, it's getting within a certain distance, and it was very close to like within like, I think 3 meters of each other, but that's the end of the arm that's going to connect onto it. And both of these round things on the sides are solar panels. So getting closer, I guess it's touching right now. It has docked. It looks like it, that screenshot, it's docked. Grabbed it, and they're out of order. It's coming towards it there. Getting closer. It's called the Canada arm. The astronaut who was doing it said this was one of the most nerve-wracking experiences he ever had, but it went perfectly flawless. And then I ended with some just some links if people want to really watch these videos themselves. It was kind of fun. It's really impressive. So I'd be happy to share that with you if that's something that you want to share with the GIS Day folks.
Absolutely. And we will, on our YouTube, we'll also post those links with this video.
Okay.
How
Stop sharing my screen. There you go.
Thank you so much, Dr. Madden. That was awesome.
Sure.
Okay, well, our audience has shrunk a little bit, but if anybody does have any questions, go ahead and type them in the chat. And now that we have the capability to unmute, we can do that too. All right, Caroline, do you have anything else you'd like to share with us about the small sat, or any information that are some good takeaway points for the crowd?
Overall, just how amazing it is that our students at UGA have put their hands on something that is now in space. I think that is kind of the large takeaway, that this is just an awesome experience for the students who've been working on this for years, the faculty, and those of us who just get to experience the fact that this very cool, hopefully it's going to transmit those images, is just going to come back to, to help with science in general and imagery and GIS processing in the future.
Yeah, when I heard them say University of Georgia, that just was
right.
So wow.
Sure.
Okay, well, I guess that'll end our session for the small sat laboratory tour. And I'm going to go ahead and stop the recording now. And I want to talk a little bit about what's coming up for GIS Day week, or the week of GIS Day.